Hello, everybody. I guess I'll go ahead and get started. I'm Seth Leger, VP of Engineering at OpenNMS Group, and I wanted to give a quick lightning talk on some work that I worked on around Dev Jam this year up in Minneapolis. And I've been wanting for a while to enhance basically our REST infrastructure to make it a little richer and support some. Well, make it more uniform so that the queries are always in the same format and return more uniform response codes. And also to be able to add the ability to search and sort on more fields in an object. Because we're, especially sorting, we have really limited ability to do that in the current REST API. So anyway, I worked on moving the REST interface from using Jersey, the original reference implementation of REST, over to Apache CXF, since it's a little bit better supported and has more, it's in kind of the ecosystem for OSGI, along with ActiveMQ and Camel and a lot of other tools that we've been using lately. So anyway, the REST interface in 17 is running in CXF. All the old REST services are still there. They work just like they used to. But I added a new V2 interface that has some more advanced querying, and I'd just like to kind of show that off real quick. When I submitted the talk, I was very optimistic. I was like, well, by the time I give this talk, we'll have tons of things in this new REST interface. There'll be 4 or 5 different objects. I can show off everything. Well, there's only 2 that are actually used in the UI, and they're new. But I have worked a little bit on nodes and notifications, getting them ported forward, but they're not actually used in the browser yet. So the only thing that can do the advanced querying very well is, I mentioned in my earlier talk, the monitoring locations XML data is now in the database, and there's a DAO for that, and then a REST interface built on top of the DAO that queries the database. And then also there's a minion REST service for minion devices that are stored in the database, and it also is built using the new interface. So I can kind of show you how this works with the query language. Let's see. The query language comes as a utility that CXF supports, and the language is called Fickle. It's really only used for, its original purpose was to query, I believe, Atom RSS feeds to be able to filter out articles based on content or tags. So I figured we could all just read the RFC. It's very interesting. These keywords must be, it's very dry. Here's all the expressions, but there's some examples at the bottom here, I think. So. Basically, the idea is that you're able to construct SQL-like queries in the query string for the REST service in one block of text. Instead of providing multiple HTTP query parameters, you provide a search string in one query parameter that gets parsed and then is used to filter the content. So let's see. Here's a quick example, title hello world. So equivalence is just a double equal sign, not equals, and it supports wildcards in the forms of asterisks. So instead of a % sign like you'd use in SQL, you use the asterisk as a wildcard. And then it supports parenthetical statements and or operators. The and is specified by doing a semicolon or by a comma, and then parentheses, just like you would expect them to work. So this is pretty dry. There have been some articles written about it by the guys at CXF. So you can see the basic operators here. Equal, not equal, greater than, greater equal, less than equal. Actually, he's missing an equal sign right there, isn't he? And then and is a semicolon or a comma, and then the parenthetical statements are just like you would expect them to work. So it doesn't do everything, but it is pretty powerful for a lot of the use cases you're going to need in REST, especially any kind of string operations are pretty powerful with this. Things that are maybe a little weaker are like date parsing, and I don't know if I've figured out all of the like floating point. I'm not sure how floating points work with this. Let's see. There's one more article. Here's the docs at the CXF website that explain a little bit more how to use it. Their convention for the query parameter for this search statement is _s or _search. So I just followed that. I think our service supports both. And like I said, with date formats, I'm not exactly certain of the format you need to use. It looks here like it can be a truncated year, month, day format, which is a little, not completely standard, I guess. But let's try it out. I've got it on the, got this. So this is my new, I think I built this machine yesterday. This is running, I think, the latest development snapshot. And if you go to the admin page now, this has been reorganized a little bit in 17 for people that haven't seen it. But there's a distributed monitoring section where you can add monitoring locations now instead of editing the monitoring locations XML. So if you click on this is a little Angular app. It's kind of busy with these icons. That'll probably be cleaned up. But this is built on top of the REST interface. So I've added 4 locations in here. And so I've got 2 in Germany, 2 in the US, all in different cities, and one of them set to priority 80. So if we look at this in REST, it's the same data. So let's try adding a query statement. Oh, that's convenient. So I think I don't even need the parentheses here. I think normally you would want to URL encode the equals signs here, but it might not be completely necessary. So a couple things to note here. So I put in a search query string of monitoring area == USA, and it did filter out only those entries with the monitoring area USA. In the XML file in this case, the XML parameters are dash separated, but in the fickle statements, you need to use basically Java Bean style properties, which is camel case, or yeah, camel case. So you might run into some minor issues there figuring out exactly how you need to spell whichever parameter is here. But it'll return a 500 error and tell you in the logs, usually with a pretty descriptive statement of what's gone wrong. So if we change this to Germany, we get the 2 cities in Germany, and then we can do priority == 80 == 80. 1 with 80s returned, not equals, the other 3 are returned. So on the back end, it's taking this string and basically converting it into a Hibernate query, which is then converted into a SQL statement. So the syntax is very SQL-like. The other thing that's supported that I can't really demonstrate here because there are no like one-to-many or one-to-one relationships on this table. You can do bean-style property values like, for instance, let's say that we had a node associated with this location. We could say node.id == 4. So for something like a notification, that would work. And you should be able to filter on any field of the node, like node.asset. Building. So you could query for potentially all notifications affecting something with a particular asset string. that's the idea. Not all of that's implemented yet. Like I said, the only two that are active right now in 17 are the monitoring locations and the minion screen. So that's the idea how it would work. Let's try some parenthetical statements, like location name not equal Pittsburgh, and, which is a semicolon, priority, if I can type, priority equals 100. So that filtered out Pittsburgh from the USA list, and it filtered out Fulda, which had a priority of 80. Can change this to oh. So let's see. So yeah, that's basically the fickle query language. I don't really know what else will be in 17 at this point besides the monitoring locations, but I'd like to get more of the objects that have DAOs behind them ported over to this, because a lot of the back-end code can be shared. Since you're basically just using bean properties for everything, it doesn't really matter which bean the service is querying for. It just parses them, and it's all gets translated into a hibernate statement in a uniform way. If you have a typo in the query string, it's kind of, buyer beware. Like, you'll just get a 500 error when you try to execute the query if the bean property is invalid or something like that. So let me try to do that actually, just to see what happens in the logs, see how informative it is. Priority invalid. Oh, didn't care. That's strange. Wonder if it actually failed somewhere. Well, I'll have to figure out a better way to get it to fail. But that's about it. That's these new services should just give you a lot more power in filtering out things in the REST interface. So, does anybody have any questions? Mm-hmm.
Jeff. Limits on doing horrible long queries?
Because it's all packed in one statement, it's probably a little bit more efficient than separating it out in a million HTTP parameters. But I guess you would just be limited by the URL string length, which these days is.
I'm worried if you put in a query that's going to run forever.
Oh, like DDoS type.
Limiting the runtime of a query or the number of events returned, systems returned.
We have a limit parameter already, which should take care of.
I think the default limit's set to 10, but I don't know that you're in any more danger than you are with the current REST interface of executing an inefficient query. Let's see if that's true. It's only going to be querying fields that are mapped to bean properties of the objects. So like basically normal fields that would appear in this XML anyway. The only thing you'd worry about then is maybe there's a field here that's derived every time the query's done, and that derivation takes a long time to execute. If you were filtering on that, it might be expensive. but it would be expensive anyway to return the value in the XML, so there's probably not too much risk there. But yeah, hopefully we can implement features in the future like a more configurable list of columns, for instance, in notification or the node list that are sortable and filterable just like the current columns are. A lot of that code is just, you know, it's a lot of hard-coded filter code that's been around forever that to extend it, you have to cut and paste and that kind of thing. Whereas this is more, it's just taking the query parameters and going straight to the database with them. So. Okay. Well, thanks for your time.
What happens to the original URLs? If you leave out the V1 and V2, you just get a 404, or do you get something helpful?
The original REST interfaces are all at the same URLs, but the new interface, actually, that's a good thing to note.
But you still have to add V1 or V2, right? Now in 17.
No,
Oh,
they're at /rest just like they used to be.
okay.
The new API is here at API/v2. But I left the old REST interface exactly like it was.
So it's
So,
still in the main web app.
well, yeah, it's there. It's not in a separate web app folder. The REST interface was cleaned up a little bit, where it's separated in the code base. If you're trying to edit the REST interface, it's now in OpenNMS web app REST instead of buried in the main web app to separate it. But the version 1 and version 2 REST interfaces are next to each other in that project. So, but yeah, if you notice any issues with the old REST API compatibility in 17, please open bugs about them. We've gone through pretty extensive integration testing or regression testing with it, but they did get reworked quite a bit for 17. But, okay, well, thanks everybody.